Welcome to Chapter 6, one of the more fascinating chapters that you will study, and this is the chemical examination of urine. The chemical examination of urine is one of the easiest tests to perform in the clinical laboratory and the most difficult for students to learn due to learning some of the chemical reactions that occur on the pads and learning the clinical significance of abnormal test results. As always, spend quality time with your textbook. I strongly encourage you to make index cards with the different chemical tests on the front, and then on the flip side, the chemical reaction if necessary, and the clinical significance on the back. And don't just put the clinical significance of that one test. For example, if you have positive ketones and positive glucose, that may indicate out of control diabetes. So you would want to mention that on the card as well. For this chapter, I really want you to spend quality time with your textbook as it has a wealth of information. But again, you need to be aware that in some areas it goes farther than you need. Many of the tables have crucial information relating to tests with the clinical significance, which are potential conditions or causes of abnormal results. Use your course objectives to guide your studies and make your notes. Commercial reagent strips are the most common method used for the chemical analysis of urine. This enables rapid screening of urine specimens for all the tests listed below. And keep in mind, some strips will have a fewer number of tests and some will have more. It just depends on the manufacturer and the laboratory that's using them. Reagent strips are available with a wide range of test pads, which allows flexibility in test selection and cost control. So the more tests you have on the strip, the more expensive it will be. A reagent strip is an inert plastic strip onto which reagent impregnated pads are bonded, and it needs to be inert so it won't react with any of the chemicals that are present on the pad. The strip is dipped in the urine very quickly, and chemical reactions, which results in a visual color change, occur that can be assessed visually or mechanically. Of course, an instrument is always the better way to go because reading these macroscopically with your own eyes really relies on having good lighting. And even then, some people will have a different interpretation of the same pad. The results are either semi-quantitative, a number, and it's not quantitative because that would be an exact number, 15 milligrams per deciliter. It's usually a range of quantitation. Or it's a qualitative test. A qualitative test is one that's either positive or negative, and these results are based on a color change. The specificity and sensitivity of each test varies between manufacturers, and I'm going to be mentioning this over and over, the difference between specificity and sensitivity. Specificity is the ability to react with the substance we're looking for, that there's no cross-reaction, that it doesn't react with other substances that are present. Sensitivity is the ability to measure a clinically significant amount. And the specificity and sensitivity of each test varies between manufacturers. And if you look at a package insert, usually on the back or towards the end of it, it will give you studies that have been done by the manufacturer to determine the sensitivity and specificity of each analyte. Some interfering substances, such as ascorbic acid, need to be detected or eliminated, as they can cause false negative results. Reagent strips are used only once and then they are discarded. The strip is briefly immersed in the urine, blotted, and observed for color changes at specific times. And this is another challenge for students, is on the bottle it will say this needs to be read at this time, this one at this time, this one at this time. So you have to keep an eye on the clock and mentally make an interpretation of that pad. Reagent strips are frequently called dipsticks, and reagent strips have significantly reduced the time required for testing. Prior to this, we had to take urine and do individual chemical tests. It has reduced costs because we don't need as many reagents, and fewer personnel can run the urinalysis machine. It has enhanced test sensitivity and specificity, and it decreased the amount of urine required for testing. It is imperative that you follow the manufacturer's instructions for the care and storage of these reagent strips. They must be protected from moisture, heat, chemicals, and light. So if you have a window in your laboratory, do not put those strips in the window. The heat can cause a the chemicals to deteriorate or change to where inaccurate results would be obtained. You have to keep the strips in their original container with the lid tightly closed to prevent moisture from getting inside. The desiccant must be kept in the container with the strips to absorb the moisture. Storage between 2 to 30 degrees. 2 degrees is refrigerator temperature, 30 degrees is room temperature. Although most labs like to store them at room temperature, 22 to 24 degrees. The daily temperature must be recorded because, for example, let's say that you're keeping them in the refrigerator and when you record the temperature as 1 degrees, that's too cold. And so you have to do something to adjust the temperature to where it's within that acceptable range. Chemical strips are stable until the expiration date listed on the label. You cannot use chemical strips beyond their expiration date. There is a reason why there is an expiration date. Any strip showing deterioration, contamination, or improper storage should be discarded. For example, you come in and it's the middle of the afternoon and it's 100 degrees outside and you see the strips in the window. Then those strips potentially have changed and won't give accurate results, so they need to be discarded. Each manufacturer will provide a product insert which comprehensively covers and outlines all of the following: sample requirements and storage of samples. So does this have to be a first morning urine? How long can I leave it at room temperature? How long can I leave it in the refrigerator? Chemical principles of the test performed, what's reacting with what to give a positive result, the reagents that are contained in the pads, the storage requirements for the strips, instructions for use, and you must follow those exactly, the sensitivity and specificity of the test strips, and of most importance to me whenever I'm reading a procedure is what are the limitations of the procedure? What are things that can cause false positive and false negative results? What are interfering substances that can also interfere and produce inaccurate results? And what are some technical errors that I need to be aware of so I don't mess up the test? For example, if you have stored a urine in the refrigerator, you must bring it to room temperature prior to testing. And you must mix it very well because red cells and white cells will settle to the bottom of the container. And if you test it without mixing it up, you may miss the red cells and white cells because they're not on the pad, because they're stuck there at the bottom of the container. Product inserts must be read and understood by all new employees prior to starting their training. It's imperative that you read the procedure thoroughly, and most places will convert the product insert into a written procedure. So the first thing you do is you read the procedure, and then somebody will demonstrate the procedure to you, and then they will have you perform the procedure under direct supervision. The instructions cannot be altered in regards to testing and use. If it says, interpret that pad at 60 seconds and it's been 2 minutes, that result is not accurate. So it's very important that as you're doing this, if you're doing it manually, that you make a note of the time and the interpretation of each pad as you go, then immediately record those reactions. Quality control, or QC. We are QC'd to death in the lab. Sometimes I feel like I spend more time doing QC than I do actual patient testing. But QC testing of the reagent strips must be performed prior to use. And this ensures that the strips are functioning properly. What if the truck that was bringing these strips to the lab broke down in Texas in the middle of summer? Well, the temperatures may get so high in the container that it could adversely affect those strips. So QC is a must. It's also a check on the performance and technique of the staff because the bottles of QC, these are materials that represent human samples, and your results must fall within certain parameters. If they don't, then perhaps you're over-reading a strip, or maybe you're under-reading a certain pad. So new containers or lot numbers of reagent strips must be checked with quality control materials at a frequency defined by the laboratory in conformity with applicable regulations, especially CLIA. So new lot numbers will come in. Some labs will just check the lot number once and then use those strips in that lot number for an extended period of time. Most laboratories require QC on these strips on a daily basis. It is mandated that these quality control materials must be physiologically the same as the test samples. For example, urine must be used as the basic substance to which they may add chemicals to create positives so that we know our strips can react appropriately. QC materials for urinalysis are usually have two levels. One is normal and one is abnormal. You must have the ability to verify strips react appropriately with normal samples and has the ability to detect every abnormal substance present on the strip. So your normal control is easy squeezy because it's going to be either negative or normal. The positive control is a nightmare when you're first starting out because all those strips are changing color and you have to mentally remember which pad had which color and then record them as soon as the timing is done. In addition to the reagent strips, tablet and liquid chemical tests may also be used. These must be handled and stored according to the manufacturer's product inserts. Products are susceptible to deterioration due to light, heat, and moisture, and should be checked for deterioration prior to use. You say, well, what does that mean? Well, once you've worked in the lab for a long time, you know what the pads should look like on the dipsticks. And so you pull one out and it looks really discolored. You would not want to use those strips because that discoloration means something's wrong with the strip. Appropriate quality control must be employed when using these tests and must be done prior to using the material. And what most labs do is when a lot number comes in, somebody will go ahead and QC it because there's nothing worse than you run out of a reagent and the next lot number has not been QC'd and you've got a stat waiting to be done. So again, QC is very important. When new liquid reagents are prepared, they should be tested in parallel with the current in-use reagents to ensure equivalent performance. This is not as much a big deal in the urinalysis lab as it is in other parts of the lab. So again, reagents must be visually inspected prior to use and discarded if any of the following have occurred. Tablet discolored. The Clinitest tablets are notorious. If you don't put the cap back on immediately, they absorb moisture from the air and they turn this really weird color. So you have to throw the whole bottle out. Contamination or spoilage is evident. Incorrect storage, or the product has expired. You should always rotate the stock to where the chemicals or the reagents that are going to expire first are at the front of the refrigerator. Community colleges love big labs because a lot of times staff will stuff things into the refrigerator, push the current lot number to the back, and then it expires, and then they can't use it. And they donate it to us, which keeps our costs down. Stability of tablets decrease after opening due to repeated exposure to the moisture. To ensure tablet quality control must be performed. Quality control must be performed prior to use when a shipment is received. So what are some of the reasons that we use tablet or liquid tests? And in the past, these were used to confirm results attained by reagent strip testing. For example, you have a positive bilirubin, then we would do the icto test. Or you had a positive protein, we would do the sulfosalicylic acid test. They're also used as alternative methods for highly pigmented urine that make reagent strip result interpretation more difficult or impossible. Some tests are more sensitive than strip testing. For example, icto test for tablets for bilirubin. Test specificity differs from the strip method, the sulfosalicylic acid SSA test for protein, and the Clinitest for reducing substances other than glucose. Most of these tests are no longer performed in the modern laboratory, and we cover these because we don't know where you're going to land, and perhaps there are some labs that still perform some of these confirmatory testing. As always, prior to performing the test, review the manufacturer's instructions or your SOP on how to use them. Reagent strips are used only once and then discarded, and apparently this has been an issue in the uninformed, that perhaps they dried them out and reused them again. Testing performed within 1 hour after collection or 8 hours if refrigerated. If you do put it in the refrigerator, be sure that you allow it to come to room temperature before testing, because a cold urine may not give the same results as a room temperature urine. Dip strips in fresh urine and compare color of the pads to the color chart after the appropriate time period. Instruments are available which detect color changes electronically, which are preferred, and they're relatively inexpensive, $500. Although, because they're so cheap, they make you use a certain type of strip. So that's where they catch you. The proper procedure for using these dipsticks is to dip the strip briefly and completely into a well-mixed room temperature urine sample. Again, I can't emphasize enough that, number one, when you briefly dip it, that you don't swirl it around like a spoon, because those chemicals then can leach out of the pads. The urine has to be well mixed prior to testing it, because, as I said, the heavier elements will fall to the bottom, red cells and white cells, which may result in a false negative and a misdiagnosis of a patient. And again, it must be at room temperature. If it's been stored in the refrigerator, then it has to come to room temperature before you can test it. You withdraw the strip by dragging it across the lip of the container, and this is the initial removal of excess urine. And then you finish up removing the excess urine by blotting the strip briefly on its side to remove the additional excess urine. I had someone, I was watching them perform this test, and they turned the strip downward and then pressed on it. And I said, you can't do that, because all the chemicals then were leaching into the paper towel, and that would cause an inaccurate result. You need to do the blotting by holding the strip so that it's on its side and can then be blotted. Keep the strip flat. Read the results at the appropriate times by comparing the color to the appropriate color on the chart provided. And timing is critical for accurate results. And another thing to mention is hold the strip above the container. Don't get pee on the container. That's really gross. So you want to either have a card that you can use that you will compare your colors to, or you use the actual bottle. And it does drive you crazy, all these different timing. There's one that's read at 30 seconds, two that's read at a minute. But again, once you get used to doing this, you just are able to keep a mental record of the colors and then record those accurately.